So the next section that we're covering is dilation. So a dilation is a transformation that produces a similar figure. A dilation is described by a scale factor and a center of dilation. So the scale factor is a ratio of the length and any side in the image to the length of its corresponding side of the pre-image. So the scale factor, we will be changing the shape. We'll either be making an enlargement, which means we're going to make it bigger. And so the scale factor has to be greater than 1 in order for us to get a bigger figure. So greater than 1. Okay. A reduction is when we're going to get something smaller. Okay. So it is going to be smaller than the pre-image, and your scale factor has to be a number that is less than 1, but still greater than 0. Okay. So here it has to be less than 1, but it also has to be greater than, less than 1 or greater than 0. Okay, so I'm just going to put an X there in the middle to stand for scale factor. So then the center of dilation is a fixed point on a plane about which all points are expanded or contracted. Okay, so that is called your center of dilation. So here it says, draw the dilation of triangle ABC with the center of dilation at the origin. So that means that our center should be right here. And it has a scale factor of 2. So if it has a scale factor of 2, that means that we are going to have an enlargement. Okay, right here, enlargement. So when we do this, if our shape does not look bigger, then that means we did something wrong, but we should have an enlargement. So since the center of the dilation is the origin, the coordinates of the image can be found by multiplying the coordinates of the pre-image. So all we got to do is take our coordinates and multiply times 2. So -2 times 2 is -4. 3 times 2 is 6. 3 times 2 is 6. 5 times 2 is 10. And then this becomes 8, 4. So here, -4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. This is 8, right? And then we have 6, 1, 2, 3, 4, 5, 6, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be a little bit higher. And then C is 8, 4. So then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, and 4. And so this is our new shape. This is our image. So just to reiterate on the center of dilation, if you notice, it kind of like expands out this way. And so that's what it means by the center of dilation. It kind of expands or retracts in order to get a bigger figure or a smaller figure. So in this case, we had an enlargement. All right, the next one, draw the dilation XYZ with the center of dilation at the origin and a scale factor of 1/2. So again, our center of dilation is at the origin. Our scale factor is 1/2, so all we got to do is cut all these points in half since we have a reduction, okay? Because it's less than 1, we have a reduction this time. So our shape is going to get smaller, so half of 2 is 1, half of 8 is 4. Half of -4 is -2, -2. Half of 6 is 3, and half of 0 is still 0. So I go ahead and graph those points, 1, 4, that's x prime. Y prime is -2, -2, and then 3, 0 is Z prime. And so this is our new shape. As you can see, it is a little bit smaller. And then if you just wanted to verify that your center of dilation is at 0, 0, then if you make a point going through x prime, it should also go through x. And you can see how the points retracted. So it shrunk into the center because it's your center of dilation. All right, next section, rotation. So rotation is a transformation that turns a figure around a fixed point called the center of rotation. The number of degrees that a figure is rotated is called the angle of rotation. Unless otherwise stated, all rotations are counterclockwise. So if they don't say what it is, you go counterclockwise. If you don't know counterclockwise, it's in this direction, the opposite direction of what a clock goes. So this one wants us to rotate triangle ABC 90 degrees about the origin and name the coordinates. So I have a website that I wanted to use that I'm going to go ahead and share with you guys so that you guys can see this. So on here, I already have most of it set up. So as you can see here, well, I have the first problem set up. So point A is 4, 4. And then we have point B is 2, 1. And point C is, what do we have there? Point C is 0, 3. So then we are going to rotate this 90 degrees. So I'm going to go ahead and change my angle to 90 degrees. So let's see. Almost. That's 110, sorry. 75, 80, 85, there you go, 90. And so that's what a 90-degree rotation looks like. So if you notice here, from point A, they go to the center out to this point A, and you can see that this is a 90-degree angle. The same thing with point B, and the same thing with point C. They make a 90-degree angle. So I will show you guys how to get this in a little bit, but we're going to go ahead and it gives you the new points right here of what our new triangle is. So I'm going to go ahead and write down these points. So it is negative 4, 4, and then negative 1, 2, and last negative 3, 0. So we're going to look at the pattern, okay? So these are my x values here, 4, 2, 0. Those are my x values. And all of a sudden, they get switched positions. So my x values end up here. And then we look at our y values. So my y values here are 4, 1, 3 originally. And now it's negative 4, negative 1, and negative 3. So what happens here is not only do they switch positions, but we also get a negative in the front. Okay, so negative yx. So if you're trying to get the point, all you gotta do is flip them around and then change the y to a negative. So I'm gonna go ahead and graph my new function. So negative 4, 4. That's a prime. And then negative 1, 2. That is b prime. And then c ends up being at negative 3, 0. And that is a 90-degree rotation. Okay, so now let's go ahead and try the next problem. Go ahead and erase what I wrote on here. Let me get my pointer. And let's see. Our new points here are 4, 4. Okay, so it's still the same triangle, 4, 4, 2, 1, and 0, 3. But this time we are rotating 180 degrees about the origin. So I'm going to go ahead on here, change my angle to 180 degrees. Well, I went too far. 150, 55, 165, 170, 175, 180. So that is a 180-degree rotation. So if you guys see that, it swings around this circle and makes 180 degrees. As you can see, this is a straight line coming across this way. From B, a straight line coming across this way, and then a straight line because it is a straight angle. So we just erase that real quick so I don't have to deal with these lines. And so I'm going to go ahead and write the new points. So they actually provide the new points after 180-degree rotation. And so our new points are negative 4, negative 4. Whoops. Negative 4, negative 4. B becomes negative 2, negative 1. C is now 0, negative 3. Okay, so let's go ahead and see the pattern here. When we did a 180-degree rotation, if we look at the x values, 4, 2, 0, they all stayed the same. The only difference is that they became negative. So they became the opposite sign. They changed signs. So the location stayed the same. It's still under x, so negative x, but they all changed signs. So now let's look at our y values. So my y values here, 4, 1, 3, they still stayed in the same place. There's still the y values, but they all changed signs again. So not only did the x value change signs, so did the y value. So I'm going to go ahead and graph this one. So let's see. Negative 4 is A. And and then B is -2, -1, and then C is 0, -3, and that is our new triangle. All right, the next one, number 5, it says rotate triangle ABC, which is 270 degrees. So we're still taking the same triangle, so I'm going to go ahead and rotate it on here. Let me erase this. And I'm going to rotate it 270 degrees. Oh, I went too far. That's 300, 295, 290, 285, 275, 270. So that would be a 270 degree rotation. And so our new points are going to be 4, -4, 1, -2, 3, 0. So then we check for the pattern. So what's the pattern here? 4, 2, 0, they all switch positions. It ends up being on the y value. So now this becomes our x value. Not only that, it's a negative. It's the opposite sign. Then we look at our x values. Our y values are 4, 1, 3, and they change to our x values. So they do not change signs. They only just change position. So they flip around, and the x gets a negative. That's the only thing. So I'm going to go ahead and graph the new one. So we have 4, -4, 1, -2, B prime, and then C prime is, 3, 0. And that's it. So I do want to go over one of the problems on your Delta Math because it is similar to this little circle. So it's this one. It says rotate a figure about the origin guided. Okay, it does give you steps on how to do this. So it says follow the guided instructions below to rotate the figure 270 degrees clockwise. Whoops. Okay, so it's asking you to go clockwise. So on the other one, we were doing counterclockwise. This time we're going clockwise. So going clockwise is in this direction. Okay, and we're going 270 degrees. So let's see. It says first draw a circle centered at the center of rotation, such as the one of the vertices of the figure is on the circle. So this is what you're going to do. You're going to press the yellow circle in the middle, the dot, and then you are going to create a circle. So you can come to any of the, you can come to this vertex, that's fine. If you wanted to come to, I don't know why it keeps, I don't know why it keeps doing that. Okay, sorry. Keep scrolling down when I try moving it. Let me try with my mouse. Maybe it'll work better with the mouse. So I was using my stylus. Maybe not. Oh, there you go. You can pick this point. 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 Pick whichever point you want. I'm going to pick this point. It doesn't matter which one you pick. I'm just picking this one. Once you do that, it says click and drag to draw a line through the yellow, center, and the vertex of the circle. So since I picked this point, I'm going to have to go from the middle out to this point. Okay, and so we're going to go ahead and find the slope of this. The rise over the run, it goes up 1, 2, 3, 4, 5, and 6. And the run is 1, 2, 3, 4, 5, 6, and 7. So the rise is 6, the run is 7. So to make a perpendicular line, because it asks us now draw a perpendicular line to that, we're going to flip the fraction, so 7 over 6, and then we have to change the sign. So now we're going to go from the center of the circle, and then we're going to go down 7 to the right 6, and that'll be our new line. And so now we have our circle cut into 90-degree angles. Okay, so it'll tell you what the next step is. Let me just erase this because I don't want it to get super messy. Sorry Sorry. Okay, so we're rotating 270 degrees. So from here, and we are going clockwise, the direction that a clock goes. From here to here is 90 degrees, okay? Then from here to here is 180 degrees. Plus another 90 degrees would be 270. So that would be our answer. And then they want us to write the new point. So the pre-image was -7, -6. And so then the new point is going to be 7, 6, -7. 6, -7. Now you can also use your notes on here. Remember when you had, oh, but this one is backwards. It's going 270, but we're going counterclockwise, so we can't use that rule. I don't think we can. Let me see, the x values should stay the same. No, the x value should change signs. Yeah, we can't use that rule because it goes in the opposite direction. And then next we have -3, -7. So -3, -7 becomes 7, -3. -3. And then -1, -3. So -1, -3, this point right here, now becomes this one right here, which is 3, -1. And then the last one, 8, -8, -1 becomes 1, -8. Try values. And then it says, you are correct. You may submit to get credit. Submit, yes. So I'm going to do this one more time just in case. This one says, follow the guided instructions below. Oh, wait, this is the same one. Next problem. All right, it says, follow the guided instructions below to rotate 90 degrees clockwise. So we're going clockwise again. About the origin. It says, draw a circle centered at the center of rotation, such as one of the vertices of the figure on the circle. So this time I'm going to make a smaller circle, as long as you pick one of these vertex. Okay, so from there to there, now it says, click and drag a line through the yellow center and the vertex of the circle. So you go from the yellow line to the point that you just went up to. And then it wants us to draw a perpendicular line. So in order for us to draw a perpendicular line, we count the rise over the run. So the rise is, it goes down 1, and then it goes to the right 3. So our slope is down 1 to the right 3. So to make our new line, we're going to have to flip it over. So it'll be 3/1. And then since this one was negative, that means that this one's going to be positive. So that means we're going to go up 3 into the right 1. And this would be our new point. Okay, so then we're going to go ahead and draw that line from the center to that point, and that's how we make a 90-degree angle. Let me just erase all this so it doesn't look so messy. All right, so now we're doing 90 degrees clockwise. So clockwise would be in this direction to the right. And we're only going 90 degrees, so we're only going to the first line right here, just that one. That's 90 degrees. This would be 180. This line would be 270. This one would be 360 degrees, one full rotation. So we're just moving it over once. And then we write our new points, and then that's it. We're done. I'm not going to do that just because I don't want to go too much time. But I hope you guys get the point. We'll see you guys later. Thank you. Bye.